Warning, the video you're about to watch contains mathematics at the level of pre-calculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is yet another review video for trigonometry for a pre-calculus course. Now, because it is assumed that you've had a full course in trigonometry prior to taking pre-calculus, these videos will go somewhat quickly. I'm not going to go through a lot of explanation here. I'm just going to remind you of things. If it is the case that you need a full review of trigonometry, or if you've never taken trigonometry, I do have a video series, a playlist for trigonometry that is the entire course, or will eventually be. I'm recording it as at this moment, probably while you're watching this, honestly. So I will likely have everything up by maybe middle to end of October 2020. So that is just to let you know that this is why I kind of run through definitions and theorems here in this video and videos based on trigonometry for pre-calculus. It is assumed that you've seen all this stuff before. So this is just a reminder. All right. So we step into the trig part. You have just finished watching maybe my video on the unit circle, which included a description of the unit circle, a reminder of it, the special triangles, and the reference number. Those are all critical for this, where we finally introduce trig functions, or reintroduce. So this is the unit circle approach. It's not my favorite approach. My favorite would be the right triangle approach. However, the unit circle approach is very important theoretically. So t is a real number, and it's the p of x, y, or the point x comma y, is a terminal point on the unit circle determined by t. So you have some unit circle, and then you have a terminal point determined by t. Remember, the terminal point determined by t, it starts at the point 1, 0, and it ends, if it opens positive, then it's going in the counterclockwise direction. If it's t is negative, it goes in the clockwise direction, and this is the point x, y. The trigonometric functions are defined by the following. Sine of t is defined to be the y value. Cosine of t is defined to be the x value. Tangent of t is defined to be the ratio of the y to the x value, where x is non-zero, and so on and so forth. These are called the circular functions because they're based on the unit circle. So all of that should be strongly familiar to you. You may have also learned an alternative definition, which is that sine of t is y over r. And that is a perfectly fine definition if you're in a circle of radius r instead of a radius 1 circle. So if that's the case, then your trig functions are defined like that, if you're in a circle of radius r. However, in the unit circle definition, r is 1 because that's the radius of the unit circle, and so all of those disappear and they just become the number 1. That should be familiar to you. So let's move forward and find the 6 trig functions of an arc length of 5 pi over 4. And I'll go ahead and draw that out very quickly here. Since 5 pi over 4 is a positive number, we know that starting at the point 1, 0, the arc will be of length 5 pi over 4 in the counterclockwise direction. So I'll just go ahead and start moving in the counterclockwise direction. We also know that there are 2 pi, that's the circumference of the entire unit circle is 2 pi. So halfway around the unit circle would be 1 pi. So all the way over to here would be an arc length of 1 pi. But when you're working with these angles like this, what you want to do is you want to get pi in terms of that denominator of 4, just so that you can easily see what where you would go, what your reference number is going to be. So pi is the same thing as 4 pi over 4. We want to get to 5 of those pi over 4, so we just have to go a little bit more. So this right here, that full arc length would be 5 pi over 4. And now we're asked to find all the trig functions at this point, this terminal point. And that's going to require us to recall something from the previous video, which is our special triangles. And this is where I think really the unit circle definition, it doesn't break down or anything. It's just that I think the right triangle definition is much better, because what I'm going to do is draw, like I just did, this line segment emanating from the origin to our point. And then I will also draw a line segment, an altitude from our point to the x-axis. And that will be perpendicular to the x-axis. And we know it's a unit circle, so that distance is of length 1. We also know that every pi over 4 defines a 45-degree angle, because we know that this distance just to here is a pi over 2. So half the distance, right to there, would be a pi over 4. And therefore we know, since it's cutting the angle of a 90-degree angle in half, it's got to be a 45-degree angle. And we went through that last time, but it's good to kind of see that again this time. So I happen to know that this angle, which is going to be our reference number, is a pi over 4. But we can easily see that's also a 45-degree angle. So if I explode that triangle and move it outside, we have a 45-degree angle here, 90-degree angle, 45-degree angle. And we know from our special triangles from our last video, I guess you would call it, if this is of length 1, this would be of length 1 over root 2, and this would be of length 1 over root 2. And now you can label that point right there. And that point, because you have to label it to do all the trig functions, that point, because it's in quadrant 3, the x value and the y value are both negative, so it's a negative 1 over root 2 and another negative 1 over root 2. The x value distance here as a distance is a positive 1 over root 2, but honestly, because it's an x value and it's in quadrant 3, like I said, it's a negative 1 over root 2. Same thing with the y value, negative 1 over root 2. And as I've mentioned previously, there's no need to rationalize that denominator. In trigonometry, you can just leave it like that. Now, we're asked to find all the trig functions for that point. So that just takes us rewriting all those values. Remember, sine of t is the y value, so that's going to be a negative 1 over root 2. The cosine of t is the x value on the unit circle, and that's a negative 1 over root 2. And finally, the tangent of t is going to be the y value over the x value, which is a negative 1 over root 2 divided by a negative 1 over root 2, which is a positive 1. And then the other three trigonometric functions are the reciprocals, as you know. So cosecant of t would be the reciprocal of negative 1 over root 2. And the secant of t would be the reciprocal of the cosine, which is a negative root 2 again. And finally, the cotangent would be the reciprocal of the tangent, so that would be, again, a positive 1. Very fast problem normally. I kind of talked my way through it, but normally that problem should be very fast for you. By the way, at this point in pre-cal, you can use trig however you want to. So if you want to do right triangle trig the entire time, then I highly recommend it. That's absolutely fine. The unit circle definition of trigonometric functions allows us to quickly discuss the domains of the trig functions. So the domains of the sine and the cosine functions are all real numbers, and that is because on the unit circle, if I hop back a couple pages, since sine of t and cosine of t are defined to be the x and y values, or y and x values respectively, their t can be any arc length. So it doesn't actually matter where. I should draw axes on here so this conversation makes sense. There we go. And there we go. Okay, so it doesn't matter what I tell you t is. Wherever you land on this circle, there is an x value and a y value. So the sine and the cosine will exist no matter where you stop rotating. So that's why the domain, the values of t you could plug in for the sine and cosine is all real numbers. Now, I might as well just stick on this page to discuss the next kind of group. That would be the tangent and the secant. And those get grouped together because notice they have denominators involving x. So x cannot be 0. So therefore, this tells us the tangent is not defined, and nor is the secant, at this point right here where x is 0, and at this point right here where x is 0. Well, that point, as far as arc length, is going to be pi over 2, but you could also rotate by 2 pi. So pi over 2 plus 2 pi k would get you to that point where k is an integer. And down here, that is an arc length of t equals 3 pi over 2. But again, you don't have to just have 3 pi over 2. You could have arrived at 3 pi over 2 and then added 2 pi to that to arrive at that point again. And in fact, you could do any multiple of 2 pi. So as long as you get to 3 pi over 2 and add any multiple of 2 pi from that point forward, you are going to land on that point right there where the x value is 0. And so therefore, these tangent and secant are both undefined at pi over 2 plus 2 pi k. And in this theorem here, I write it as pi over 2 plus n pi, but it is... and I write it as pi over 2 plus n pi because, sorry, I kind of didn't even think about that, but because you can group these two together by saying, listen, I got to pi over 2, and if I add pi, I will get here, and it's undefined. And if I add another pi, I'll end there, and it's, again, the tangent and secant are undefined because x values are 0 there. So, therefore, actually, I can cover all bases by easily just saying, let me zoom in here and erase this one first. I can cover all my bases by easily just saying the domain is all real numbers except for, sorry, my eraser's not working for some reason, pi over 2 plus pi k, or I guess since I'm using n, I'll just use n since that was being used in my definition or my theorem. All right, so that will cover all those bases. And now let's just talk about the other two, which are going to be the cotangent and cosecant. So cosecant and cotangent, notice their denominators are y's, and we do not want y to be 0, and that happens on the x-axis. So just by a similar argument to what we did for the tangent and the secant, we can say, well, if you start at 0 and you add any integer multiple of pi, then you're on the x-axis, and so your y value is 0. And by definition, the cotangent and cosecant are undefined at those points. So pi n would be where the domain does not exist for the cotangent and cosecant. And that's what I say in this theorem right here. So that gives you kind of the idea why the domains are what they are for the trig functions when you saw them in your trig course. And as we know, the signs of the trig functions, I'm not going to explain why because you guys have all seen this, but just remember, all the trig functions are positive in quadrant 1. Only the sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3, and cosine and its reciprocal are positive in quadrant 4. And the mnemonic, or what we use for that, is all students take calculus, right? So there you go. Now that will be the wrap up for this video. It's just a quick reminder of the trig functions. In the next video, we'll quickly go through some values of trig functions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.